Oh, you said three? Yeah. I got you. I did.
All right. Hello, guys. This is our first week one lecture of GAR. So thank you guys for coming. Sorry we started a little bit late, but it shouldn't be too long. We'll get you guys out of here before like 7, probably, hopefully. But so we'll be going over an electrical overview, battery safety, and then no machine install and setup. So if you guys were here for like the build day, it'll be pretty much like most of the same things, just like in a more organized format. And then we'll also start like with getting the car running and running algorithms, how you can do that, and also a basic ROS tool overview.
Okay, to start with, we're just going to give a general overview of the components of the car, just so you know what's going on. Uh, to start with, with just autonomous driving in general, you have the sensors, detecting information. Then that goes to the software, that does the control algorithms, um, and that sends back to the hardware for controlling, actuators like motors and servos. So for the Robo Racer specifically, the central, control unit is the Jetson Orin Nano. This is going to be, where the bulk of the, controls um, and calculations are going to be performed. Um, and the major sensor that we're using is a LiDAR that sends out a light light signal and detects how long it comes back, and it uses that to map the area around it. That information is communicated via Ethernet, although I believe that USB is also an option. Um, so the Jetson takes that information from the LiDAR, does the algorithms that are programmed into it, and then sends the outputs to the VESC. That is the VESC, electronic speed controller. And this is going to be the unit that is controlling the actuators, the servo, and the brushless motor. Um, it communicates with the servo via PPM, and with the brushless motor with the three-phase. It's a three-phase loop.
So for these systems, these cars usually have like we have a 330 brush steel. If I'm correct, a brushless BLDC motor going onto here, and from what we see along here, we have our monitor showing peripherals, our car running everything else, and on top of it, you're gonna see the Benkin electronic speed controller that we use specifically for this car, and then we have essentially like it's not a motor controller. It's only a single board computer, but we have our Justin or Nano that sort of houses the entire brains, and then you communicate over SSH with your like laptop, all the relevant peripherals, and you're able to like see from there from the ECU itself, though, anything data collected from the lidar, and also be able to do some additional steering. So when you're connecting it through, like say, your controller, you'd be essentially controlling it through there onto the computer, onto the car itself.
So yeah, it's a quick overview. LiDAR detects the world, gives that information to the Jetson Orin. Jetson Orin calculates, what it wants the car to do, gives that information to the VESC, and the VESC takes that information and decides what signals to send to the motor and servo. Uh, for power, the car will be powered with a LiPo battery, um, which I'll go slightly more in depth into that on the next slide. But the LiPo battery is connected to the power board, which has buck boost converters, so that it can, because as the battery drains, the voltage goes down. But the Jetson Orin and LiDAR need a consistent voltage. So the power board takes that and outputs or takes the input from the battery and outputs 12 volts to both the Jetson Orin and the LiDAR. The VESC connects directly to the battery. So the VESC and by extension the motors and servos don't interact with the power board. For this power board, these two right here these are the switches on the right in red. Those are what you use to turn the power board on and off. Um, when you're putting stuff on the power board, very important that you make sure your polarity is right. This is very expensive. Some of this equipment is very expensive. I think the LiDAR is over $1,000. Um, the VESC, what, like 450, something like that. So you really want to make sure, when dealing with the power that you have your polarity right. Uh, LiPo batteries LiPo stands for lithium polymer. Uh, they're used or they have a lot more they're a lot more like consistent and higher power um, than other RC batteries, but um, they're also a lot easier to break, a lot more delicate. Uh, these are this rating right here, the 5,000 milliamp hours. That's the capacity. Um, that's the amount of energy in the battery. This 3S right here is that's the number of cells. So there are 3 cells here, and they add up to 11.1 volts at max charge. This right here, 25C and 50C, is the discharge rating, and that's how much the battery can safely discharge. And you multiply the discharge rating by the capacity to get the maximum amperage you can pull out of the battery. So for 25C, for sustained use, 125 amps, and for burst, 250. Does that look right? Yeah. This is what you'll be using to charge the batteries. Um, uh, there's 3 modes. There's fast mode, balance mode, and storage mode. Um, Fast mode, I know that Chris said to use fast mode before, but when I was doing I was doing a little bit more research, and apparently like fast mode, it might leave the cells at different charge, which could drain it or damage the battery in the long term. So it's generally safest to use balance mode when charging, unless you're not using the battery, like you've done your work for the day, you're putting the car up, in which case you want to charge it in storage mode, which this image is a little bit hard to see, but the buttons are labeled, there's instructions on it. I feel like it's pretty self-explanatory to use when you see it, as long as you remember uh, balance mode when you're using it, storage mode when you're not.
And also with both those that, over the course of time that you're practicing these cards, so we're going to be there to, assist you, remind you, hey, your balance, fast mode, and then go from there. So then over time, even if you don't get this right now, it'll just come out of.
Uh, yeah, so these are good practices. Don't leave the battery unattended when charging. Um, Make sure that you unplug it when you're done. And also you should be putting them in the bags, the lipo safe storage bags. I don't think we've been doing that. But we should start doing that soon. Um, do not leave it connected to the car.
Bring it to the barbecue.
Hmm?
Bring it to the barbecue.
Yeah, yeah. This is a very important one. When you're done using the car, make sure you unplug the battery. If you leave it plugged in, uh, it'll discharge. Battery won't be safe to use. Um, yeah, and the rest of this, typical, if you hear noises, you know, burning, anything like that, unplug the battery. And, once again, be very careful when you're checking polarity. Um, yeah, is there anything else you can think of for keeping in mind for what might like discharge it too much?
I mean, obviously don't put a fork in between them, but otherwise I think you got it all figured out. So.
Or that we got a mic on here on the laptop.
Oh yeah, I mean, just don't put a fork in between the outlets, and you should be fine. So, uh, And now we're going to be switching up to Ethereum.
Okay. So if you guys were here for the build day, it's pretty much a lot of the same, but it's like a lot more organized now. So you guys will be able to see it in a much more, I guess, memorable fashion. So first of all, for No Machine, hopefully you guys have this all installed. If you don't, might as well just go and install it after this meeting or like whenever you want, whenever you're available. So the link to install it is nomachine.com. And the reason why we use No Machine rather than something like SSHing, which is also like a really popular practice, is we use some visual applications like RViz. So RViz is just kind of a way to visually see what the car sees. Um, so you can't really use SSH to see this visual application. That's why we use No Machine in the first place. And also these slides will all be posted and a recording will also be posted after. So if you guys need to look back on any of this, you're free to do so there. So for setting up No Machine, you're gonna create a new connection that looks like this. So you don't need to have the name as F110, but the main thing that you need is just the port to be 4000 and the protocol to be NX. And then this host IP, we're gonna get it from the car. So we'll go over that right now. So first, getting the IP, we're gonna have to first turn on the car. So to do this, we're gonna find the battery. So usually an appropriate battery comes at around 50%, like above 50%. Obviously, if it's like below 10, I would not use it. Like below 20 even, I would not use it. Just be really cautious with them. But plug it into the car. You can check the battery, the level of battery by using the battery tester, which is like a small little thing with like a little meter on it. And then you flip on the switch. There's like it's really weird. The power board for some reason is like flipped. So it's like the off is on and the on is off. But so you just flip it onto the off location. I mean, you can do it until you get it to be like everything lights up. You'll see everything light up when it does light up. But yeah, so lights will come on, and then you can plug in the HDMI to an external monitor. So the HDMI to the NVIDIA Jetson, you'll plug that into like an external monitor. So then we can get the IP address. So to get the IP, we have to then once the cart turns on, we're gonna log into the F110, which the password is 1234556, and then we'll wait for the computer to actually log in. It might take like a few seconds to like a few minutes. It really does depend. And then we'll open a terminal. So to open a terminal, you have to also plug in the keyboard as well, like with the USB. You can press like the Windows key and it'll like show up a little like spotlight search, and then you can just type in like terminal, and then you're gonna type in the command ifconfig, and then you'll get like this big kind of wall of text, and the one that you're going to be looking for is under inet. So here I have it kind of circled. So this inet IP is like, for in this example, it's 10.138.205.98, and that's going to be your IP address that you're going to put into No Machine to actually connect to the car. So keep in mind, this IP does regularly change about, I think, every day. So like every 24 hours roughly it changes. So if you're using the car on the same day, most of the time the IP will be the same, but if you're using like on a different day, it might be different. So to actually like once we have the IP, we're gonna connect using No Machine. So on the laptop, like on this slide, you're gonna obviously put the actual IP address there, and then we're going to be connected to the car. And there's like some dialogues in the No Machine application. You'll see like what is the it'll ask you to log into the password. You just put 12356 again, and then you can unplug the external monitor, and then we have this little like headless, I think it's called a headless ghost HDMI adapter. This thing you just put into the HDMI output, and it'll just allow you to control the car. Without it, it's like weird. There's like no visual output to actually be controlling, so it won't let you actually control the car, but or like control the no like control the desktop. But with it, it just lets you control it. So just plug that in. And then next we'll actually get into running the algorithm. So now that we have it on No Machine and we have like a terminal open, we can run the basic F110 stack algorithm that actually allows you to control other algorithms and control the car via like the controller that we were using last time. So to run the F110 algorithm, first we need to source a terminal. So whenever you have a new terminal, or also whenever you build a terminal, which we'll get to that later, but you just have to remember to source a terminal, and this kind of makes it able to see all the other files. So if you're doing something and you see something like, oh, this directory cannot be found or something, then just know you probably haven't sourced a terminal. So, but once you do that, it'll see like all the other files in the terminal. And then you're going to run the stack with ROS2 launch, F110 stack, bring up launch, .py. And don't worry, all these commands will be like on a slide later, so you don't really have to memorize them. I usually just reference, like I have like a little cheat sheet that I just reference for all my commands and stuff. So once you run this command, you'll see like a huge bunch of like logs and stuff, but that's not really important. You can now control the car. When you're controlling the car, you're gonna hold down the left button on the controller. So that's like the top left bumper. And then you can use the left joystick to control throttle, so that's up and down. And then you can use the right joystick to control steering, so that's left and right. And now, once you have that main stack running, we can go into how you can run like other algorithms. So this is just an example using follow the gap, but obviously this can be tailored to any different algorithm. Like you might be using like wall follow, you might be using pure pursuit, just any algorithm. It's like pretty much the same step. So you open a new terminal, and remember when you open a new terminal, make sure to source it. So that's the source install slash setup.bash step, and then you're gonna run the follow the gap algorithm. So in this case, for the follow the gap, the command is gonna be ROS2 run GT follow gap, GT follow gap. And then to actually run the algorithm, you're gonna hold down the RB on the controller. So it's LB to manually control it, and then RB is kind of the deadlock to control or activate whatever algorithm's already loaded onto the car. So just a warning, make sure to have the main stack running. So that's this one. Make sure to have this one running before you do any other algorithms, because if you don't, it won't it'll just turn on like by itself, and the only way you can really end it is like control seeing the in the terminal. So the reason why we use the main stack is so that we can control the algorithm with that deadlock switch. So it's way easier to like turn off, turn on. Like if it's running into a wall, you can just turn it off by like letting go rather than like getting no machine open and control seeing it. So that's why we use the main stack. So this is just a command summary. This will be uploaded obviously, so you can just use this to reference when you're actually like doing work. So yeah, so a couple things that we didn't mention here. Colcon build is pretty much the command that you're going to use. Like, let's say you change an algorithm, like a file, like let's say you change a parameter, like the speed or something in the follow the gap algorithm, like config file. Then you have to use Colcon build packages, select, and then GT follow gap, and this will rebuild that algorithm. If you don't do this, then it'll kind of still use that same or the old build file. So and then after you do this, you also have to make sure to source a terminal again, or else it'll still use the old build file. So we'll just get into a really quick ROS2 overview. Nothing too crazy, but so ROS2 stands for Robot Operating System 2, and you can think of ROS as kind of like it's like a layer in between. It's not an actual operating system like Linux or something. The cars still have like Ubuntu and stuff. It's just a way to centralize all your inputs and outputs um in like your robot. So for example, the cars, they have like a lidar that they hear from, and then they also have drivers that they control to. And ROS just makes it like a standardized, like general way to control the outputs like the drivers and the motor controllers, and also hear from the inputs like the lidar and the IMU. So nodes are kind of, you can think of it like a worker with like one job. So like the lidar is like its own node, and it relays the lidar input, and then the driver is another node that operates the steering and controls the throttle. Topics are like a kind of a channel. You can think of it like a whiteboard almost, like where the nodes share their information to. So slash scan is a topic where this lidar relays all its inputs. So programs can also subscribe to topics to listen to those messages. So the lidar will be publishing to slash scan, while something maybe like the follow the gap node will be subscribing to slash scan to hear what it's saying. And then messages are the actual like information being relayed. So yeah.
Okay, so the VESC, I guess to explain a little bit further what the VESC is, it's Veeder, is that Vetter? Veeder electronic speed controller. Veeder or Vetter, whoever it is the guy that designed it. And so it's basically just it's an ESC that has a ton of extra like sensing and tools like the VESC tool. Um, so, um, yeah, you'll have to interface with it to change the PID controller that it has. That is the algorithm that it uses for controlling the motor itself based off of the RPM or speed value that it gets. and just changing any other configurations about how it controls the servo or motor. So to do that, you'll have to download this tool right here. I believe you can download it on your phone too. Um, but these are instructions for on your laptop. So you download that app, power the vest with a battery, connect it to your laptop via USB. You can just use the same USB cable that it has to connect to the Jetson. Um, and when you're doing this, it's safer to make sure that your laptop is running on battery power, um, because you don't it could damage the VESC and your laptop. Isn't that what happened with Chris? Right, yeah. Was this what happened? Was it because was it his laptop plugged in or
No, it's just Chris. He was in here, plugged into that third, and I guess just the second he plugged in, the something happened here. Where yeah, not he ended up having to get like a whole new computer, but it was a worthwhile upgrade because you need to do that to then be worth it. But
yeah. And for the
more than more than
and in case the mic didn't pick that up, our vice president fried his laptop once connecting a Vesk to his laptop. And we never, we don't know exactly why, um, but this could have been why. So yeah, just don't have your laptop plugged in um, when you're plugging in the Vesk. Once you do that, you can just open the app, um, and it has an auto connect feature. And yeah, now you're connected to the Vesk, and you can change whatever settings or get whatever data you need. Um, yeah, I think that's all.
but I think now we're going on to more hands-on portion. So, here we go on takeaway for a no machine. Pretty solid so far. I didn't train a lot of people here, but been here before, but we're just trying to make sure we can have like consistent curriculum so then everyone can up to speed on what's going on in the card itself. So then we're making sure everyone's caught up to speed on what's going on in the card itself though, and everyone, no matter what system you're on, can go in, turn the car, run it for whatever you need to do. So yeah. Want to add on anything else, Trevor?
I might have a little demo if it's if you want. I have a ROS demo from our autonomous robots class that kind of gives a good overview of what each, I guess, thing we went over for us is if you want to see it.
Sure.
Before we end the recording, does anybody have any questions? No. Hmm?
Like, are you required to run for a minimum amount of time to set battery capacity?
You mean like when we're doing for races?
Yeah.
Usually
Different style.
it's not really endurance style though. Most of the time though, they're doing like a race line optimization. So like in certain
I just
excuse me.
like
It's not a Le Mans style race though. It's more like a map optimization. So for example, when you look inside these tracks over here, you're gonna see various curves and such. But the reason it's done this way though, one, because it's easy to set up. Two is because like it's gonna allow the team and like also T Lab to test out whether or not they can do proper like scanning of the system itself and then create like their own like I forgot what it's called, the race line simulation of the best path to go. That's something we're actually gonna be going over later throughout the semester though. Once we get better equipped with the simulator, race line, follow the gap, and automatic braking system. Not in that particular order, but it is something we're gonna be covering though. So
Did you say, were you asking like why we were using a LiPo battery? Oh, it's just, I mean, the alternatives are just really, especially when you're at the LiDAR and the Jetson Nano, the alternatives are just have really short battery life. So even though this isn't an endurance thing, um,
it's more of a voltage capacity.
it's like more.
right,
It's
yeah.
also it's very much in line though, because a lot of this is based on like correct me if I'm wrong on this. I believe it's either MIT or UPenn that made this original stack, and they were trying to adapt it based on the original RC car, like hobby infrastructure that's out there, and is based on lipo batteries. So they just wanted to use something that was a little more accessible at the time period, and just transfer it over. So then it's a lot easier for anyone to get into this. So You bet. Thank you.
Yeah. All right. Thank you guys.
Oh wait, and we're gonna post these slides so you can look at it later. But also, in addition to asking us questions, you can use the Robo Racer slash F1. F110's the old name. Now they're calling it Robo Racer. So you can use those resources online. I believe their website is just roboracer.ai. Is that right? Yeah. And that has a lot of this information, about setting up the Jetson, using the vest, blah blah blah. So there's that resource too.
Yeah. So I want to say thank you all for joining us for our lecture. We're going to be sticking around a little bit more if you have any additional questions, but next week we should be starting up with our office hours. And unless we have any tentative change to our curriculum, we'll be doing an alternating structure of lecture, office hours to go on to allow time for people to both come into lecture, ask some questions, and then also on your own, go read through documentation, practice what's going on, get a little bit familiar with what's going on, and then also come in to see us so then we can help you out. So I would highly recommend doing so.
And did you have how to install the simulator in the
Oh yeah,
slide?
simulator we'll do in one of the lectures in the future, but for now I would just try to get no machine installed. And then if you want like office hours next week, I'll probably be helping like maybe set it up. You could have demos as well, like on the car as well. Probably help with raw setup. Yeah.
Yeah.
And if you're electrical, I would have the VEST tool um, installed as well. Or I mean anybody, because it's just an app that you can download online. It's really easy to set up.
Yeah. And from there, I would also recommend anyone with an electrical, it'd be highly recommended to download either Altium or KiCad, preferably Altium, because that's what a lot of our UF libraries are based on. And from there, we'd be starting more into general, another go through of the electrical architecture, but also getting started on like basics of like Altium training and how to get through on like getting PCB design set up. So that'll be mostly done between like me and Tyler on a separate schedule. So
Yeah. Oh, and by the way, if for Altium you do need a license. That's another reason why Altium is just kind of better than KiCad. But it requires a paid license. If you're a student, you can get it for free. And we'll go over how to get that license and set it up
yeah.
in the future.
There will be documents being released later, either tomorrow or later this week, though. I'll be putting into the electrical channels for how to essentially go and install Altium on your devices. Like, all you need to do really, though, is sign up, use your email, follow it all, and as long as you get like something set up, you should be fine. It's pretty self-intuitive, but like, I'll be releasing a document just to outline how to get it set up properly to your UF account so it doesn't mess up. So, and anyone have any additional questions?
Oh, those are PCB design softwares for those of you that didn't know.
Well, for one, a lot of us are going to be focusing on creating either VEST, power boards, or just like general like telemetry board systems that we'd be using either for research-based purposes to sort of in order to assist the T-Lab, but not be as involved with like the papers, the writing, and the academia. You can get yourself more involved, or we'd be working on like say projects that are meant more on like longer term projects that are meant more for like general competitions, such as like the Robo Racer stack of what's going on, and also the exploration into longer term projects like the Indianapolis Autonomous Challenge or the Thomas Karting series.
So the lecture today was, just, getting all of you up to speed about how to use the car as is, which obviously you don't need to use Altium for. But if we're going to design our own boards and add to it in the future, then that's why we did that. Does that answer your question?
All right, good. Well, I want to say, if you want to stick around for a little bit, hang out with us maybe while we're here. I want to say thank you for, taking time out of your day to be here. So, appreciate it.